Мы переходим к обсуждению сферы применения
move on
технологий
to
искусственного интеллекта в
describing
медицине.
another
Искусственный
application
интеллект
for
уже
the
сейчас
AI,
помогает
which is
разрабатывать
healthcare
инновационные
medicine.
лекарственные препараты,
AI helps develop new
заболевания.
novel
Ну, а
drugs
также
and
дает
diagnose
возможность
diseases. Also, it gives an opportunity to people with visual and audio impairment to communicate with the rest of the world. Catherine Mohr, president from Intuitive Foundation, which is a foundation that has its
Thank you, and thank you for the introduction. Good afternoon, and what an excellent opportunity to be able to follow Tom in this talk as we talk about a lot of some of the two sides of the coin of AI in healthcare. And I'm going to be talking to you about how we can use it to increase accessibility and how we can think about ways in which we can use AI in education, in surgery. But before I go into really thinking about the stuff that's way in the future or even in the present, I want to talk a little bit about the past. How is it that we've gotten to here in the kind of technology that we're using in medicine? And what sort of an effect has that had on our health? And to do that, I'm going to look back about 100 years. And this is a graph of essentially life expectancy versus the gross national product or gross domestic product of any individual country. Each one of these dots represents a country, and the size of the dot represents the population of the country. And you can see more or less where they're all falling on a health wealth line. So as the country gets wealthier, it gets healthier. And this has to do with increased access to food, education, sanitation. And this is more or less the same line that had been going on for about 100 years prior to this. As countries got wealthier, they moved up the line. As they got less wealthy, they moved down the line. But this line had been fairly consistent for about 100 years. And for those of us over the age of 50, you'll notice something fairly sobering, that the average life expectancy for most of these countries over 100 years ago was less than 50. And the few little outliers out there really don't make up the bulk. But a lot of things changed in the last 100 years. And I'm going to play this forward. That dip at the beginning was our big pandemic over 100 years ago. We're going to see similar dips showing up in the next few years. That's all hell breaking loose in World War II. But amazingly, after World War II, you see all of these countries moving inexorably above that 50-year life expectancy line. The economics of this, the GDP per capita, is normalized to today's dollars. So those poorest countries that you see down in the $500 to $1,000 GDP per capita are still the poorest countries. And yet, without any change in their wealth, they have moved wholesale up above that 50-year life expectancy. The other thing that's happened is that curve has flattened out. It's gone from being fairly steep to less steep. And so countries are less dependent on the wealth of the country in order to be able to have a good life expectancy. So what happened in that 100 years that hadn't happened in the previous 100 years? Why did this line change so fundamentally? And I'm going to argue that it is technologies. Medical technologies like vaccinations, which we're again all dependent on right now to help us end this current pandemic. Technologies like the development of antibiotics and the pharmacology for chronic diseases, and big changes in surgery. Now, you might ask, is surgery really deserving of this place among these powerhouses of global public health, of antibiotics and vaccinations. And I will make an argument that it actually is, and it's something that we ought to be paying much more attention to. Globally, there are 300 million surgeries done every year. And of those people who get surgery done, 4 million die within 30 days of having their surgery. Now, sometimes there's really just medical errors. Sometimes we have, we get to operate too late. But overall, that's not a good number. Sometimes people aren't properly trained. We would really like to see all 300 million of those surgeries be 100% successful without that kind of death rate. Even with that, billions around the globe lack access to even the most basic surgical services. And what that means is there's between 7 and 17 million potentially preventable deaths if we could get those people to early surgery. And so how does this compare when we're thinking about global public health? Even if we were to get rid of all of those, even if we were able to fix the problem of access to surgery, if we don't improve the way we are doing surgery and how we are doing it, we're going to see, giving everybody access, about 450 million surgeries done annually around the globe, and 6 million people dying within 30 days of that operation. And so compare this to 10 million deaths a year of cancer total around the globe. 4 million deaths a year from HIV, TB, and malaria combined. And we've seen 2 million deaths from COVID in the first year of the pandemic. You now start to get a feeling that being able to improve access to surgery and being able to improve the execution of surgery is an imperative when we're thinking about global public health. And this is especially important in Asia. 88% of the next billion people to enter the middle class are going to be in Asia. When you look at a place like India, 380 million people entering the middle class, that is more than the size of the economy of the United States, of people coming online in a space of about 10 years and needing these kinds of surgical services. In India right now, the educational infrastructure can turn out 400 oncologic surgeons per year for a population of 1.25 billion people. And we really start to see the mismatch of what this demand is that is coming and the ability of the educational infrastructure to be able to meet that demand. And so when we think about one of the most important things that we could be producing over the next few years, it's clinicians in low and middle income countries being able to get to the point where we can meet this kind of burgeoning global demand. And when we think about infrastructure, most people think about hospitals, like the one that you see in the background. But you can build a hospital in a year. When you look at the people that are training and who are providing care in that hospital, it takes 10 years to train those people. And so when we think about infrastructure issues, it is the people and the education that we are working towards that are going to be some of the biggest challenges that we're facing. And to give you an idea of what a technologically enabled adoption curve will look like, you can look at this graph of cell phones per 100 people over the space of time from 1985 to 2018. And this is in the same set of economies that you're seeing on the right-hand side, which is the growth of medical doctors per 1,000 people in those exact same economies over the exact same period of time. We went from 0 cell phones, because they really weren't invented yet, to more than 1 cell phone per person. That gray 100 line is more than 1 cell phone per person in that economy. And this is because this is a fast adoption type of technology. It's very complicated where you first make it, but the adoption is very easy to deploy. You contrast that with the kind of growth that we see in medical doctors, and even though people want doctors every bit as much as they want cell phones, that growth is gated by something that's very different. It's gated by our educational infrastructure. This is the paradigm that we need to break in order to be able to meet this global demand for surgeons. And this is the kind of thing that we can start to think about doing with AI. Because scaling surgery, scaling to meet that demand needs surgeons. It also needs the hospital infrastructure, the nurses, and the support staff. But at its most fundamental level, it needs a revolution in the way we're doing education. It needs a way in which we can scale education beyond the way that we've ever been able to do before. Now, robotics in surgery have given us a lot of really interesting insights into how we can scale surgery and how we can train our surgeons. This is the Da Vinci surgical robot. It's a soft tissue robot. The surgeon sits at the console and performs the surgery with the robot nearby, and those instrument arms that you see are down through small incisions in the body of the patient. This is the business end of the robot. This is the bit that is actually doing all of the manipulation. And it is following exactly every motion that the surgeon's hand is making. And so you can see the surgeon sitting at the console is making the motion like they are doing that suture. And that is being done at the end of the robot instrument, whether that's deep down in the heart, repairing the valve, as you see there, or in the abdomen. We also have robots that have single clusters of instruments, and they behave in a way that the group of instruments come in, again, the same use of the controllers, and the surgeon has the feeling of being completely telepresent inside the body with their hands and their eyes in there with them. There's even other forms of surgical robot that are catheter type, long, slender robots that can be threaded down through something like the airway and given navigation out to a tumor that they'd like to sample and make sure that that tumor is, or that nodule is benign or cancerous. The reason why you want to be able to do something like this is if you can get out there and you can sample that nodule when it's still only about the size of a grape, there's an 80% chance that if that's cancer, that person will live for 5 years, more than 5 years. If you wait until that has grown to about the size of a grapefruit, then there's only a 15% chance that that person will survive 5 years. And often the time between that small sample, that small nodule, and that larger cancer is fairly short. Time is of the essence, and being able to navigate out through these airways, being able to take a pre-op image, segment the image that you're seeing, and be able to give that surgeon navigation out to that airway are all ways in which we are bringing AI and machine learning already onto the robot itself. So, but one of the key aspects of this, as you think about us being able to both determine what the path should be and display it to the clinician as they're going, we have to be able to know the tip of that robot and every motion that the clinician is doing and every interaction between the patient and that robot. That is completely new. In the past, surgery has been see one, do one, teach one, but it was a largely unobserved process. nobody from the outside could see the learning that was going on or could see the motions that were actually happening on a micro scale. When we pass the motions that the surgeon is making through the robotic interface, we're now able to measure everything. We've turned what in the past was a largely unobservable process into data. And we can now analyze all of that data in order to be able to think about how can we train surgeons better in that space. And robots have been coming out for the last 25 years in surgery, and we are now at a pace where we're doing more than 1.3 million surgeries per year. That's a lot of data that we get to start to look at. It lets us see how surgeons learn to do these procedures. It lets us watch a surgeon go from being a novice at using robotics to being an expert. It lets us see them, it lets us also see how 1,000 surgeons do exactly that same step. It lets us start to build educational models where we are bringing AI techniques to bear on this data set and being able to build this kind of coaches, essentially. And so the first step in this, in being able to bring AI onto this, is being able to parse the task in the way a human would into different subsets of where that surgery is being performed. We can look at the video data, we can look at the kinematic data, and we can start to be able to deconstruct the surgeries into all of their individual component parts. We then can, as I said, watch how one clinician's abilities are changing as they are learning in that one step. And we can also compare that to how lots of different surgeons do that single step. This gives us the ability to start to give feedback in real time to surgeons about how their performance is going. Now, it doesn't take an AI or a machine learning algorithm to be able to spot the difference between this expert and this novice here. It's a fair, you can see that the novice moves in much wider motions, and the expert is tighter, much more economy of motion. What you can't tell from looking at something like this is how we got from being the novice to the expert. What was the path? What were the tasks that the novice did very poorly, but that this expert was doing extremely well? And so when we think about how we train pilots, we don't have them when we put them on simulators, we don't have them simulate the same blue sky day, no wind landing over and over and over again. We extract from all of the data of the ways in which pilots fly and the conditions under which pilots fly, and we train them on the things that they find the most difficult. We train them on the things that they don't encounter that often. We can do the same thing as we're training surgeons. When we are working in simulation, we can look at the tasks that they're doing, the ones that they have the most difficulty with, the ones that show us the biggest range between novice and expert, and we can build our simulators to be able to have that surgeon practice that thing over and over and over again, and be able to practice things that they won't encounter that often, except in an emergency situation, so that they're very prepared. This is a fast track, go from novice to expert. Because in the past, the way surgeons have trained primarily is on just as many surgeries as they could be scrubbed in for. And so it was the repetition, and it was the, but they were mostly training on routine surgeries with the occasional difficult aspect of it. And this is why it would take so long to train to mastery. with simulation, we can really start to move people down that curve a lot faster. Now, you might ask, I started out talking about the global shortage of surgeons and surgeons in low and middle income countries. And then I went to expensive robots and I said, and expensive robots are the answer. And that is not true. What we can do with these robots is we can gain the insights that we need to think about how it is that we're going to build coaching for these surgeons. But one of the key things that we noticed is that, yes, the kinematic information was very helpful from the robot for building these models, but we didn't really need it. We could build most of the coaching models that we needed from video alone, which means that you can start to, just from pure video, be able to build these kinds of AI models for coaching surgeons. And this led to the work that I'm doing today in the Global Surgical Training Challenge, which is a global challenge prize looking at bringing these kinds of tools, bringing what we're talking about in terms of self-assessment into the world of training surgeons in low and middle income countries. And the goal of the Global Surgical Training Challenge is, can we bring lower cost simulation-based surgical training into the low and middle income country training paradigm in such a way that it can be self-administered, outside of the infrastructure that we that hasn't been able to respond rapidly enough to this need for surgeons. Can we take clinicians who are working on a daily basis in one clinical area and allow them to self-train to add a new surgical procedure into their armamentarium? Can they master a new skill anywhere in the world at any point in their career, because the coach is AI. The coach is helping them do their own learner-administrated simulation-based training. So we needed novelty in this area. We're really pushing the boundaries of what we can do with these fairly simple simulation-based training, and recognizing that assessment, this ability of the module to be able to give targeted feedback so that the clinician can practice the thing that they need to be practicing and not practice bad skills, is key to us being able to scale this kind of education. And so our challenge that we sent out to the world was to provide the clinical curriculum and the context, build standardized simulation experiences to build that psychomotor skill, and build into it actionable, self-guided feedback for this purposeful guided practice. The surgeon's still doing the surgery, but we are building into both the models and the feedback how they can learn and practice these skills. And so the program goal was to create a framework within which the surgical practice got them to competence and confidence. But the ultimate goal was to dramatically increase global access to surgery. And this is really where AI can come in. And so in the Global Surgical Training Challenge, we had participants from 44 countries around the world, and it is now 10 groups with PIs from low and middle income countries that are building programs that range from everything from treatment for ectopic pregnancy to surgery to release contractions associated with burns, being able to do external fixators for bone, and techniques for first responders in Guatemala to be able to treat massive hemorrhage so that they can transport the patient and get the patient to the hospital still alive. So I'm really excited about the quality of the modules that have come out from this program and where this is going to go with the addition of being able to improve the way the coaching and feedback is happening in all of these modules. So along with this, we have been building toolboxes for anyone who is building simulator onto this open source platform and then be able to use the tools that we've given them to teach themselves how to build self-assessment modules and how to measure all of the things that they need in order to be able to do these kinds of analyses on their videos. And so we have seen the kinds of simulators that people are working on be everything from kind of rubbery task trainers that they create that can get made on site to full VR immersive situations that people can access through things like their smartphones. And so you always need to make sure that it's not a tech push, that we're not saying, oh, we've got this great new technology and we want to apply it in this area, and so the technology leads. It always needs to be the clinical needs that are leading, and then we can harness that technology in order to be able to meet those clinical needs. But like you saw in the video at the beginning, where we were looking at this dramatic increase in life expectancy because of these new medical technologies, I expect that we're going to really be able to tackle some of those last areas where we still see such significant morbidity and mortality in the arenas of just not having access to enough surgery and enough surgeons. And we're going to be able to get there because of these new technological tools that we're using, even in incredibly austere environments. And so with that, I'm happy to take any questions.
Thank you very much. It was very, very interesting. The robots are fantastic. Of course, we've got some questions for you. The first one, can you name the most promising directions of AI development in the field of medicine, except for surgery? You've mentioned pilots. Maybe anything else?
Well, so I alluded to it in sort of in the middle portion, where I was talking about image analysis, and where we can take preoperative images and we can segment the portions of the body in order to make it be like a 3D map of the patient. We're using AI and machine learning techniques in order to be able to improve those maps greatly, but also to help clinicians spot the different kinds of pathologies. There's a huge amount of training that people do in order to be able to see and diagnose those pathologies, but bringing these machine learning techniques in helps people analyze them and spot them much faster. And the other thing that we can do is we can navigate. You think about, I'm using navigation technologies all the time to drive my car, give me GPS. We can do GPS in the body, and it allows us to navigate to the tumor around spots that are that we don't want to touch, essentially. And we can use a lot of these AI techniques for that as well. I think of them as augmenting the surgeon, giving the surgeon sort of additional superpowers of perception and navigation that work alongside them. And it's not just surgeons, it's clinicians in all ranges of medicine that will be able to use these analysis and navigation type tools.
Thank you. Could you name the most valuable lessons for the future of global healthcare learned during the COVID pandemic, COVID-19?
Well, one of the things that we learned is that we didn't all have to be in the same spot in order to be able to get things done. And one of the biggest collaborative teams, all of those teams that are collaborating and making these simulators, many of them have never met in person. They only met over a virtual platform that we put in between. And we've also learned that training, which we've always thought was something had to be done right there with the trainee and the instructor, that even training of something as complex as the psychomotor skills associated with surgery can also be done more at a distance and more remotely. We also learned that so much information can be gathered from just the video that and that we didn't need a lot of the kinematic motion data in order to be able to build real AI coaches. And so all of those combined says to me that the education is going to be much more virtual, and our work is going to be much more virtual, but we can collaborate across time zones, across geographic barriers in order to be able to do really amazing novel stuff. That was the biggest takeaway for me from the pandemic.
Yeah, collaboration is the best solution, right? And now another question about surgeons once again. Training the next generation of surgeons is a great responsibility. Can we trust artificial intelligence with it? Are you sure it works well?
So one of the things that I think we've been seeing over and over again is that people usually think, when they think about AI, is AI taking over the procedure and doing it entirely and autonomously. All of the examples I've been showing have been about the AI working with the surgeon. And so when we are thinking about these first stages, as we're bringing AI into medicine, as we're really using it in order to be able to help us meet these global demands, it's still very much a hybrid model. We're not ceding all of these, we're not ceding all of the teaching, we're not ceding all of the judgment, we're not to an AI, we're augmenting the clinicians with these tools. Eventually, these things may be more autonomous, but in the early stages, these are all going to be hybrid models, and there's still a human in the loop.
Okay, AI is implemented right now in different spheres of medicine, and some people are really nervous because of that. How can we lift this nervousness and comfort them?
Well, one way is to reassure them for a lot of this clinical work, the clinician, the person, is still in the loop, and it's still making a lot of those final decisions, that the AI is a decision support. But I think the second most important thing is just looking at the data, that medicine gets better, it gets more accurate, it gets faster, and it gets fairer because more people have access to it. And I think people's discomfort with one aspect of the technology will start to go away as they start to have more familiarity and see the benefits that it can bring.
Catherine, thank you very much. It was really a pleasure to talk to you, and thank you for your presentation and for your answer. Thank you.
Thank you very much.